Hello, my name is Mohammad Nazi. I am from Group 5, and in this video I will be talking about Network Address Translation (NAT), about how it works and why do we need it. Okay, what is NAT? Network Address Translation (NAT) translate the IP address of devices in a local network to a single IP address. NAT modifies network address information in Internet Protocol IP datagram packet headers while they are in a transit across a traffic routing device for the purpose of remapping one IP address space into another, which means translating private IP address to public IP address. The router can be connected to a DSL modem, cable modem, T1 line, or even a dial-up modem. The uses of NAT. There are three main uses of NAT. First of all, is to connect to the internet. Secondly, is to change your internal address. Third is for basic load sharing of TCP traffic. Okay, situations where NAT is used. Firstly, when our network is built with private IP addresses and we want to connect it with internet. Okay, as we all know, we need to connect with internet. In order for us to connect to internet, we are required to have a public IP address. In this situation, we can use NAT devices which will map private IP address with public IP address. Secondly, when two networks which are using the same IP address scheme want to merge. In this situation, NAT devices is used to avoid IP overlapping issues. Thirdly, we want to connect multiple computers with internet through the single public IP address. In this situation, NAT is used to map the multiple IP address with single IP address specified by the port number. How NAT works. To understand how NAT works, let's take an example based on what needs to be accomplished by the user, which we will elaborate more on the type of NATs in detail. Next, structure of NAT. Okay, this is one of the example of the structure of NAT. Private addresses. Okay, these are the reserved IP range for private networks. Type of NAT. Three main types of NAT rules are used today depending on what needs to be accomplished. Static NAT, dynamic NAT, and port address translation, but known as overloading. Okay, now let's take a look at the example of the simple network system below. Firstly, we will look at PAT, which stands for port address translation, also known as overloading. PAT converts a private IP segment range to a single IP, and each private IP is separated by port number when translating to public IP. Okay, this is by far the most popular NAT type, and this is what you are using in your home networks. When your computer sends data to the router then will take a look at its source address, the port number, the destination address, and the destination port number. Now the port number is very important here. Not only it will distinguish which device the data belongs to, but it will also tell the device which application that the data belongs to. The router will then swaps out the private source address and port number, then swaps it for a public address and port number. The port number will often stay the same, but if it is already being used, then the next available one will be selected to keep track of which public addresses belong to which private address. The router then builds a NAT table. This table matches the private address and port number to the public address and port number. Once the router swaps the address and adds it to the table, it rebuilds the data and sends it on its way. Okay, now when the data comes back, the router again looks at the addresses of the source. The source address is now the address where it came from some web service somewhere from the internet. Okay, the destination is now the public address and the port number. The router looks at this and checks the destination against the NAT table. If it finds a match, the router will swap out the public address and port number for the private address and port number, and it will send it on its way. Next, dynamic NAT. Dynamic NAT actually goes against everything what I've just said. It doesn't save addresses because it's a one-to-one mapping of addresses, but it's still a type of NAT. the dynamic NAT need to manually create a pool of public addresses, in which this would require you to purchase these public addresses from your ISP. For example, telecom. Our pool would be represented. Our pool would be represented by the pages icon on the right side. Okay. Apart from that, dynamic NAT works pretty much the same way. When data comes in, the router looks at the source and destination address, swaps out the source address for the first available public address from that pool. And then it sends it on its way. Okay, now when the data comes back, it again looks at the source address and then looks at the destination address. If it finds a match in the NAT table from the destination address, it swaps out for the private and then send the data on its way. After this is done, the public address will return to the pool ready to be used again. Yeah. Lastly, we take a look at static NAT. Static NAT converts one private IP address to one public IP, 1-to-1 ratio. Static NAT requires you to manually type in the entries to the NAT table. You tell the router which private address and port number translate to which public address and port number. Okay, once this is done, it works just like the other two versions of NAT. When the data comes in, it checks the NAT table for the source address. When it finds a match, it swaps the address for the public address and then it sends on its way. When the data comes back, eject the address against the NAT table, swap the public address for the private address. This version of that is mostly used for public servers like web servers, for example, where the port will always be 80 for HTTP. So NAT translates private addresses to public addresses. It does this by using an app table to keep a record of this translation. And lastly, I am going to talk about the future of NAT. Remember how IPv4 had 4.2 billion of addresses? Well, IPv6 has a lot more addresses, noting 3.4 multiplied by 10.8 to the power of 38 addresses, so many that it requires a hexadecimal system to display the addresses. And that is how much IPv6 addresses we have approximately compared to IPv4 addresses, which is a lot. In other words, there are more than enough IPv6 addresses to keep the internet operational for a very, very long time. If we can give every device its own public addresses, we won't be needing any NAT anymore, which means routers now can only focus on their core business, which is routing network protocols. This is a good news, but why haven't we switched to IPv6 yet? Yet the depletion of IPv4 was predicted years ago. However, progress has been slow. Only a small fraction of the web has switched over to the new protocol. In addition, IPv4 and IPv6 essentially run as parallel networks where exchanging data between these protocols requires special gateways. Were it not, as it won't have any major impact on our life. Most operating systems actually support IPv6, including Mac OS and Windows XP. However, many routers and servers don't support it. Making a connection between a device with an IPv6 address to a router or server that only supports IPv4 is impossible. IPv6 is also still in its infancy. It still has a lot of bugs, security issues that still need to be fixed, which could result in one giant mess. I think that is all from me. Thank you.